Okay, great. Just so everyone knows, this is a recorded event and recording has just been started. So welcome again to our 2023 series of CPD Import 43. Thank you for attending our first event, which is coming to you from Unilin, formerly known as Extratherm. They have a good relationship with the Institute and are coming in to speak about regulations to climate challenge energy targets and accounting for embodied carbon, discussions around Part L, the LETI, document from London, climate change challenges, etc. So I won't go into any more detail, and I'll hand it straight over to Martyn. As usual, please do ask questions in the chat box. These will be fielded towards the end during our Q&A session, and I look forward to having a discussion with Martyn at the end.
Thank you. Share my screen with you guys there. So again, we're Unilin Installation. My name is Martyn Randall, one of the specification managers. I'm going to go through the regulations to RIBA Climate Challenge, look at energy targets and accounting for embodied carbon. So just as a quick agenda, so this is a very data-heavy presentation. It's 83 slides long, so I can let people have a copy of it. There will be bits that we'll skip over slightly, and I'll try and cover off as best I can most of the information here. So we're going to go through the regulations in Part L in England, so the 2021 in dwellings. We're going to have a look into the introduction of the future home standards, which is Part L 2025. We're going to then introduce embodied carbon as the missing metric. We have a discussion on the RIBA Climate Challenge on their 2030 targets and how that looks. I must stress that obviously CIAT are also looking at their challenge targets, but it will be a collaboration like the RIBA Climate Challenges as well. So they will be talking to RIBA, I'm sure, as they will LETI, the UK Green Building Council and others. We'll look at the challenge targets, and then we'll look at life cycle assessments and the Royal Institute of Chartered Surveyors guidance. Quick touch upon LETI before we look into environmental product declarations. Have a quick look at our CO2 report, looking at 4 dwelling types and their embodied carbon, and then we'll touch upon insulation specifications to meet all of that. So as we've said, we've changed our name as of the 1st of January this year to Unilin, our parent company. So we've been part of Unilin since 2016 when they bought us. And it's only recently that they've wanted to take over the brand and grow the Unilin insulation brand into a €1 billion company. So we have manufacturing facilities, 2 in the UK in Ross-on-Wye and Chesterfield, and then 2 in Ireland in Ballyconnell and Navan, and then further manufacturing facilities across Europe, making 9 in total. We have a vast range of insulation materials. Again, I won't go into them in too much detail, but basically thermal, typically rigid thermal insulation solutions. So we have a new range which is called Eco 360. We're the first manufacturers of PIR in Europe to use a bioenhancement, which is rapeseed resin. It's available in our full fill, partial fill and general purpose board. It's got an increased thermal performance of 0.020. The packaging's been reduced by over 50%. It's also biodegradable, and we state there less waste on site and that's generally will get involved in material takeoffs, but that's typically it about us. We'll go into environmental product declarations in further slides when we link it through into embodied carbon, but these things can be sourced from a manufacturer. They must be independently third-party assessed. When you're using a life cycle assessment, an EPD must be available on the software that you use, and one of those examples is OneClick. OneClick are very similar to Revit, who won the BIM race. OneClick appear to be winning the race to house and be the platform for running embodied carbon targets. And where you don't have an EPD available, you must use a generic material score, and like most generic material scores, they're not very good. So we'll go into Part L. We should all be fairly familiar with this. On the 15th of June of last year, come into effect with a 1-year transitional period. It was a 31% lower carbon emissions than previously in the 2013 regulations. And through SAP 10 itself, we've got a primary energy target, which is new to us. We've got the CO2 emissions target, which has been reduced, the fabric energy efficiency target, which has been reduced, the minimum standards for fabric, and then fixed building services as well. So we'll touch upon those just now. So the primary energy target, so it's new to us. It's measured in kilowatt hours per square metre per year, and it's the primary energy used by a dwelling for its heating, lighting and hot water, and it can be influenced by things like the building fabric, and there's other factors like boiler efficiencies and renewable inputs. We've then got the CO2 emissions target, which is measured in kilograms of CO2 emissions per square metre per year. Again, this has been with us since the concept of SAP from a compliance point of view. And again, I think we can all accept that reduction in CO2 is the primary objective when improving our building stock, as it contributes so massively towards global warming itself. Then we got the fabric energy efficiency standard. So this again relates to really the fabric first approach as an energy assessor myself. And if there's any on the call, this really is the starting point when you start looking at SAP from an energy assessment point of view. You can then start to look at the CO2 and the primary energy, which again are a lot easier. So again, it looks at, I suppose, the energy, looking at the fabric, I guess. So the more energy that's used to heat it, the worse it is. So again, if you can reduce that fuel consumption with the building fabric itself, and it doesn't matter whether that comes from a clean source or not, it still has to be paid for by a consumer, which is really relevant at the moment, obviously, with rising energy bills. So looking at more fuel to heat, to heat the building, the cheaper it is to run, and therefore it becomes a major step towards the elimination of fuel poverty. So then you've got the minimum standards. So again, you can see they're listed on the table. These are absolute backstops, so I won't go through them all, but effectively what they're in there is part of the recipe of SAP. If you've got something like a dormer cheek, which you want to look aesthetically pleasing, you can go as high as 0.26 in that as an external wall element. Very small area, it would be offset then against other elements. So by making the floor slightly lower, you can make the walls slightly worse. So it's a balancing exercise. And then you've got the fixed building services. So these include things like heating systems, where you've got boiler efficiencies and time and temperature controls, which are also set. Y value of 0.05. So basically thermal bridging measured in psi values, it's measured linearly. There's 44 junctions in total. So you've got things like the external wall ground floor junctions, lintels, sills, reveals, intermediate floors, eaves details. So all of these are measured linearly, and as a psi value, they get added together quite simply, and they form a Y value. So we know that U values are fairly common. Everyone seems to know about them. They're repeating thermal bridges. The Y value is the non-repeating thermal bridges. As a total, it's a penalty that gets added in SAP in the background. So if you think you're achieving 0.15, but you've got a really high Y value, then your overall U value is a lot worse. The air tightness is 5, so that's remained constant throughout SAP. We're still looking at mains gas boilers. Again, we're not quite ready to switch over, and I think that's more about getting the industry ready for commissioning and stuff. So we're still looking at gas. We've then got wastewater heat recovery systems. So quite simply, sit on the trap of a bath or a shower, take the waste transfer heat coiled around what's going back into the system to heat it up. Therefore, it's like boiling a half-boiled kettle. Less energy is used to heat that water up. That then disperses down for a foul drainage. You've then got photovoltaic panels measured in 40% of the ground floor gross internal floor area divided by 6.5 for a residential point of view will give you the kilowatts per hour. We've also got the external walls at 0.18, party walls 0, fully filled and sealed, floors at 0.13, roofs at 0.11, doors at 1, and windows at 1.2. So again, we are finding it extremely difficult to make the notional dwelling pass. There's influences like the glazing and stuff, which all come into effect. But we're seeing the U values certainly in the floors, typically around about 0.11, 0.12, and then the walls lowered as well. But again, I must stress, obviously, from a fabric first point of view, when you look at the fabric itself with the Brell report, the Building Regulations England Part L that goes out as part of the SAP, if you fail the fees, the fabric energy efficiency, after the building's been built, it's very difficult to comply. You can't use renewables or anything like that to offset. So again, it's about getting it right at the first time. So that introduces us to the future home standards. So what to expect for the future. So again, the government has outlined their response. There is a consultation period now in 2023 with the legislation published in 2024 and implementation in 2025. So again, the government, we had 2013 in April 2014. We've had 2021 in June 2022. So hopefully, again, these standards and targets can be met, but there is some history behind delaying them slightly. So they are expected to be 75 to 80% lower than Part L 2013. They expect to do that through high levels of fabric standards and low carbon heating systems. It is subject to further consultation, but the use of gas, oil and LPG heating systems as part of the removal of the fossil fuels will no longer be permitted. They will reduce the primary energy, CO2 and fabric energy efficiency targets, and then they'll review the minimum standards for the fabric and fixed building services. So when they talk about the future home standards, they talk about heat pumps. When they mean heat pumps, they talk about air source heat pumps, which operate very, very well. The reason that they talk about air source over ground source and water source is it's a cheaper capital cost, not necessarily the most efficient overall, but again, it's a cheaper capital cost, and we tend to look at that first, being driven from that point of view. So they have a draft notional specification. So you've got a floor U value at 0.11, so slightly reduced. The external walls at 0.15, again, slightly reduced. The roof remaining the same at 0.11, which is quite a significant challenge in both flat roofs and sort of pitched roofs along the rake of the ceiling. You've got windows at 0.8, so going down to triple glaze. You've got doors that remains constant at 1, as does the air permeability. The heating appliance going down to that heat pump system. The emitter type, so how the temperature is distributed for a room, goes to low temperature to suit the heat pumps themselves, which work typically well below 45 degrees. A natural ventilation, which remains standard, and no PV at the moment, and no wastewater heat recovery. So a comparison, I don't want to talk too much about zero carbon homes in 2016, which never happened, but Part L 2013, Part L 2021, and the future home standards of 2025 are relevant. So you can see that 0.13 to 0.11, if we're talking PIR, it's a 25 mil reduction or increase, sorry, to increase to 0.11. 0.18 to 0.15 is the same in PIR from a partial fill or a full fill point of view. From a roof point of view, we've gone from 0.13 to 0.11 in Part L 2021. So again, we mainly insulate through the bottom chord of ceiling trusses typically. So again, that mineral fibre is built up, or if it's again for a pitched roof, it can be up to about 40 mil, depending on where the insulation line sits. Windows, you've got going from standard double glaze to triple glaze, doors at 1, air permeability at constant at 5, the low carbon heating system coming in, so air source heat pumps. The emitter has already changed in 2021, and things like retrofit, we're going to get used to retrofitting. So again, if we're going to be installing low carbon heating systems in a retrofit point of view, we have to consider how the emitters are working. So radiators have to be upgraded and perhaps even doubled or times 2.5 in size to accommodate the low temperatures that run through them, or underfloor heating, which again works on that from day one. The ventilation is standards. PV really only comes into effect 2021. Whether we see it in the future home standards, it looks unlikely, but it will complement, obviously, the air source heat pump and the electrics for everything else. There's no wastewater heat recovery beyond 2021, and then your Y value remains constant at 0.05, so a relatively good Y value. So again, looking at the details that we have available on the system, we can, in a standard 2-story house with a truss roof, if you like, you can generally get down to about 0.03 or slightly lower. Just again on that, 0.01 or less is deemed passive house and no bridge. So there's no metrics for embodied carbon. So we're always looking at an operational carbon point of view. So the climate challenge remains unaddressed. So again, that's an introduction to the operational carbon, which leads us into talking about embodied carbon. So introducing it as a metric. So that, again, I'll skip over these, but you've got the Greater London Authority, the Manchester draft local plans. There's UK Environmental Audit Committee, and then you've got the Construction Industry Council as well. Everyone's talking about embodied carbon. I just come off the UK Green Building Council's presentation at 11 o'clock today. Government have committed to a Part Z regulation in embodied carbon. So again, it's a hot topic. Which introduces us. So I'm going to mention RIBA, unfortunately, in the RIBA Climate Challenge. So 2 days after the UK announced their decommissioning of the grid, the version 1 of the RIBA Climate Challenge came out. And again, they go on to state that the climate emergency demands urgent action and leadership by architects and the wider construction industry. We must act now, ensuring that new and retrofit buildings deliver net zero whole life carbon in advance of any future regulations. So they've gone on from this. They brought out version 2 in July of last year, and they were aligning themselves with LETI, the Greater London Authority, the UK Green Building Council, IStructD, the Royal Institute of Chartered Surveyors. So it's a collaboration. They were making sure they were getting this right. They looked at the future home standards from an operational carbon point of view to incorporate that within the method as well. So again, this is where the introduction came. They have targets, so again, we'll have a quick look at an educational, but they've got residential, commercial, educational, commercial, industrial mixed. So all of the targets change slightly depending on the use of the buildings. So they've set out with operational energy at having less than 35 kilowatt hours per square metre per year. They've then got embodied carbon at under 625 kilograms of CO2 emissions per square metre. And this is one of the big changes that we saw in version 2. Version 1 had that at under 300. And you know, we were looking at this, as were many others. We were finding this a real challenge, a real challenge to meet those targets. So again, they were lobbied quite heavily and changed those targets. We've set improvements to come, and I'll explain how those improvements will come as well. Then there's potable water use at under 75 litres per day per person. So you've then got health and well-being, so looking at indoor daylight and air quality. You've then got biodiversity, so it's about making the site more biodiverse enhanced than it was previously. And then you've got the delivery period as well, with a 1 year post occupational testing. So like I said, they also have targets, and you can see here an educational school target. Obviously, we're not living in that building, so all of the targets are slightly different. So the delivery period itself, so one thing we don't do when we measure SAP, we don't look at any post-occupational testing. It's not a compliance regulation. So again, there's things like insulation not installed, or things not working efficiently, or that could all be missed. So again, having this 1 year summer winter cycle of having data submission is really good. They are talking about making it longer, and it links to habits. So again, it's good finding out that somebody's using a system. Perhaps they're using the air source heat pump in the wrong way, in which case it becomes it's not working properly, and therefore the energy efficiency isn't as set out. You can educate then somebody as to how to use it, and that typically takes a little bit longer in time. So again, having a longer period isn't a bad thing. So things like Passive House also have post-occupancy testing, but typically with a SAP compliant building, you wouldn't expect to do that. So just looking at operational energy and the definition, so it's measured in kilowatt hours per square metre per year, and it can be taken from confirmed energy bills or more advanced metering systems. That's the easiest way. The RIBA Climate Challenge does allow you to use both grid and on-site renewables. So for example, you can use PV generated on-site to meet those targets. And again, whilst we're talking about them, we're talking about here net zero. So we're talking about offsetting measures that are set out within the challenge. And you wouldn't be offsetting. So again, we do go on to say, as part of the UK Sustainable Outcomes Guide, effectively, if you're looking at a design stage, you can use things like SAP or PHPP. So SAP is obviously what we'd use from a building regulations point of view. The PHPP is Passive House version. Again, this is just at design stage to estimate the demand, but they do go on to say that in the case of space heating, that demand should be between 15 to 20 kilowatts allowed for in the design itself. So just looking at embodied carbon and embodied energy definitions, there's a common misconception referred to when we look at embodied energy and embodied carbon. So embodied carbon itself looks at the sum of CO2 emissions associated with a product or service, as per the below there, looking through raw materials, manufacturing, packaging, distribution, use, disposal in that cycle. We quite regularly see that cycle linked to embodied energy, though, which it doesn't relate to, which is the sum of energy in kilowatt hours to produce a product or service. But just to understand embodied carbon emissions, they're generated from the processes that are associated with sourcing materials, fabricating them into products and systems, transporting them to site and assembling them into a building itself. They also include the emissions due to maintenance, repair and replacement, and they include the final demolition and disposal stage. So you'll see here the pie chart, you've got 51% of the whole life embodied carbon emissions coming up to practical completion. So that's A1 to A5. You've then got carbon emissions in use, carbon operational emissions regulated, then unregulated. So anything that's regulated is covered under building regulations, heating, lighting, and hot water, and unregulated is everything else. So just looking at embodied carbon calculations. So just as an example, you've got 481,000 kilowatt hours of electricity powering a data center. That's the embodied energy. So that embodied energy and the consumption itself doesn't change, regardless of whether it comes from, say, a wind source, which is a low embodied carbon source, or coal, which is a high carbon embodied carbon source. It remains the same. However, the carbon content of the energy source determines the carbon footprint. Ordinarily, if I was with you guys or with everyone right now, I would do a show of hands. I like to interact. I mean, such a good topic, but such a long amount of slides. But what I would say is, forget your businesses for a second. As an individual, does anyone on the Teams call know what their carbon footprint is? And I don't expect anyone to know that whole entirely accurately, if you like, but an idea. So again, there's various apps that you can use. The WWF have one, the Tree app have one, and it's a way of simply understanding where you sit on your carbon footprint compared to the rest of the UK and compared to the rest of the world. It's just one of those things that, again, when we talk about a climate challenge and we talk about all of the obstacles in our path, they've actually calculated, quickly, it takes about 3 or 4 minutes to calculate where they are approximately. So it'd be interesting if anyone on the course has done that, or during my presentation, whether anyone does it. Mine's 11.07, just to give you an idea. So looking at embodied carbon from a life cycle assessment, then an LCA, it's the methodology for assessing environmental impacts associated with all stages of the life cycle of a commercial product or process and service. So we've got things that we refer to. So we've got cradle to gate, so A1 to A3, and again, it looks at that raw material extraction and the manufacturing. You've then got cradle to grave, so again, looks at the stage all the way through to disposal. You've then got cradle to cradle, effectively. So it's a more specific kind of assessment where you look at the end of life disposal of a product. As a responsible manufacturer, we're constantly developing ways for recycling our products, but as an example, you take a roof timber out of an existing building, and that gets chipped down, gets put into being something else. That's cradle to cradle. When you've got cradle to cradle certified, that goes beyond that stage. So the best example of that is like a piece of stone that goes into a wall. It can come out of a wall at demolition stage and go into another wall in the same process without having a process in between to change that product itself. So potable water targets, you'll be pleased to hear there's only one slide on this. So at the moment, we've got a UK average of 141 litres per day per person. We've got a tick box within SAP itself for 125 litres per day per person. There's lots of local authorities that have got reductions on this already. But again, they're looking to reduce that to below 75. So we need a methodology when we calculate anything, really. So the Royal Institute of Chartered Surveyors have assisted with the life cycle assessments. So to calculate the embodied carbon, quite simply, they've broken things down. So an external wall broken down here is concrete blocks, the insulation, the bricks and the mortar. You times them by the embodied carbon conversion factors in the EPDs, the GWP score, and that equals the embodied carbon of that element. You then add them together, and that's the total embodied carbon element of the wall. The categories then that you have are then added together, and they're divided back by the gross internal floor area to give you the total embodied carbon. So again, you can see substructure, superstructure. The components are then split down into subcategories. So we're just going to have a quick look at LETI. so referred to as the Low Energy Transformation Initiative, previously London. So again, the biggest mistake that they made with that was the word London. But again, this is more open. Again, I'm going to mention the name again, but RIBA is restricted. It's restricted to architects and practices under RIBA. LETI is open to engineers, planners, academics, housing association professionals, and so on. So and CIAT and MCIOB. So they're more open from that point of view. They're not restricted to London, and obviously they do collaborate with others as well. They've split their carbon guidance down into two. So two targets. You've got upfront carbon and then total embodied carbon. So upfront carbon is A1 to A5 to up to practical completion. This excludes sequestration itself. But you can see the targets are banded there. It looks a bit like the green guide used to with those targets. So there's set ways to improve those targets as well. Whereas you've then got the whole life embodied carbon stage, so A1 through to D, through to recycle, which you can include sequestration. And you can see where the RIBA Climate Challenge sits. It sits at a band B there, under 625. As I said, it was previously under 300 as an A+. So again, there's obvious room for improvement there that can be made. And that's going to happen with all the good work that the industry is doing from a manufacturing point of view, going back into this from an EPD score, sorry. So we'll have a look at those environmental product declarations now, EPDs as we call them, and their role in calculating embodied carbon. So they do measure the environmental impacts of a product for its life cycle. They're based over 100 years. It's done to EN 15804. It was A1. It's been changed to A2 in July of last year, which we're fully up to date on. And there's a number of stages that we talk about. So we talk about A1 to A3, which is the product stage, which is raw material supply and manufacturing. A1 to A5, the construction stage, so transport to site and assembly. B1 to B7, the use stage, which includes maintenance, repair and replacement. You've then got C1 to C4, which is the end of life, demolition, transport to disposal, and then disposal itself. And then a D stage, which is the recovery or recycling stage. The main thing that you look for in an EPD is the environmental product declaration. So previously, before the EPDs took over from the Green Guide at the end of 2021, effectively they had a GWP score of less than 5%, and that typically looked at the blowing agent only, whereas it looks at the whole life cycle assessment now. So the GWP measures the carbon dioxide and greenhouse gas emissions associated with the manufacture and use of a product or service, sometimes known as embodied carbon or carbon footprint. So over 100 years, you've got a GWP score there of 1 for carbon dioxide, things like methane, so again, rotting timbers or food or something. Would be 25. You then got hydrofluorocarbons in refrigerants from 124 to 14,800. So there's a lot of work to be done there, and we'll talk about refrigerants in a minute when we link them back to air source heat pumps. It also looks at the ozone depletion potential, the ODP. So previously that was a figure of 0%. Again, these figures are incredibly low. To decimal points move a lot, so 0.00000. Before you encounter a number. So they are incredibly low, but they look at the ozone depleting gases causing damage to the stratospheric ozone layer, reducing its ability to stop ultraviolet light entering the Earth's atmosphere. So the GWP is the main thing you look for, but something else that might be known is the ozone depletion potential. Again, various questions when you look at EPDs, they're not that easy to interpret. They're not like a BBA certificate itself, so that they're specific to materials. They're specific to the manufacturer location of those materials. So you can't use an EPD score that comes from another factory when the materials come out of a different factory, sort of thing, because it all links back to processes within that factory itself and the efficiencies. They're not linear, so you can't readily change a thickness by dividing it back and times it by the new thickness, which makes it complicated when people use thicknesses within an EPD that you can't buy in the industry. So therefore, the thickness is important when you do a comparison. They tend to have an expiry over 5 years. So to get an EPD with an expiry or a 5-year valid period, you have to have a year's worth of manufacturing data. You can say that you've got 90% recycled element within your product, but unless it's demonstrated within an EPD, it can't be used. you've got to go back to what an old EPD would say. So again, there's lots of good work going in. They cost about £9,000 per EPD, so it's quite a significant cost to doing them when you've got quite a vast range. So again, there's a strategic approach. So you might not let it wait to the 5 years, but strategically, depending on what your maintenance plan is, say within your facility, perhaps you plan on putting a lot of solar on your roof. You wouldn't really want to put your EPD out until that work had been done, because it will impact things that go on. So again, there are people out there like ourselves that are doing significant work in the background, which will significantly improve the EPD scores. So reading an EPD then, just looking at specifically A1 to A3, looking at that stage, we've got two scores. I'll skip to the next slide. But we've got two scores, which is 1.60E plus 0.2 and then 1.64E minus 0.1. And it's about the movement of decimal places. So again, normally I'd have a little bit of a guess around the room, but one's 160.2 and the other one's 0.164. And it's about the power of and the moving of decimal places. And it's because, again, we're looking at the GWP, but it's because of the ozone depreciation potential, which has got that significantly low score, that's used. So I've spoken to people like OneClick, and I've sort of said to them, isn't it far easier to demonstrate the actual score, seeing as that's the most significant thing we're looking at, rather than making it overly complicated? But again, that's not going to happen. That's the way they're doing things at the moment. And again, it just makes them that little bit more difficult to read and understand. So it brings us on to an independent assessment on embodied carbon that was commissioned. So we did this with XCO2, who they've got backgrounds in engineering, architecture, and environmental science, and effectively what they were commissioned to do is look at the life cycle assessments in accordance with the RIBA Climate Challenge over 4 dwelling types, which was a detached, semi-detached, mid-terrace, and apartment block. And the aim of doing this was to look to see if we could achieve the RIBA Climate Challenge using traditional construction methods. And we started this process on version 1. So we were looking at under 300. And obviously when version 2 came out, it was a lot easier to achieve, but still quite onerous at the same time. So there's various standards that this assessment was created to, which again, you'll have a copy of this should anyone want to wish to look into. There was an independent quantity surveyor used to quantify materials, and in accordance with both LETI and RIBA criteria, the landscaping and pavements were excluded. And again, we were interested in the building, not necessarily its surroundings at that time, because the building was constant. So again, we worked with OneClick, and there are other softwares and databases that are available, but we worked with OneClick on the LCA. For anyone that's familiar with things like SAP 10 or SAP 2012, it's quite a simple process, inputting measurements, drop-down boxes, finding information. It's just, again, it's making sure you find the right information, like you would find the right boiler. You have to find the right EPD to be able to be used. Again, we're not claiming that we're architects here or designers. As you can see, these aren't aesthetically pleasing, but we weren't picking easy boxes either. So we had a detached house there, a semi-detached terrace block, an apartment block, and you can see listed there the gross internal floor areas. Similar to SAP, the higher the gross internal floor area, the easier it is for compliance. So you will see a trend when we look at the scores in a minute. So the specifications were basically a default future home standards. So we took the operational carbon of that and looked at a specification that would meet that. We then improved the future home standards using improved EPDs with ours and others for recycled elements. We then looked at more of a passive house, so an MVHR passive heating design, and then electric panel heaters. So looked at direct electric heating, which again, as the grid continues to be cleaned up, it's going to become more and more likely. I'm not wanting to see things like night storage heaters, but similar things. Again, from a compliance point of view, the more and more work that goes into the grid. So again, there are a baseline specification and improved specification, you see highlighted there, and again, just an enhanced refrigerant that was used as a replacement as well. So again, you go through the stages, A1, A4, A5, then through B1 to B7, C1 to C4, and then effectively comes out with a total embodied carbon as you go down through. There are some fairly high material scores there, but there's some fairly big elements to them. And again, we come in with a score of 584, so slightly below target of where it needed to be. So there is a common theme throughout throughout these. So you've got the detached house, and it's always the baseline being the highest, then the improved, then the electric heating, then the MVHR. And you can see listed down on the right-hand side the elements as they go into them. So color-coded. So again, semi-detached, slightly failing on the embodied carbon, obviously on the improved, and quite a lot on the baseline. But again, there's going to be a lot of good work, and again, slightly failing on the baseline of the apartment blocks. There is a lot of good work going in. So if this same exercise was done in, say, 3 years' time with the same manufacturers, with expected EPD scores set to lower from those manufacturers, they are going to be significantly reduced. So again, we will see them naturally come down. So just breaking down the A1 of the stages, you've got A1 to A3, which is 50. The RIBA pie chart had A1 to A5, which was 51. We're at 55 when we analysed ours, so not dissimilar. And again, you can see there it's highlighting the A1 to A3, the B1 and the B4 and 5, and it links to a later slide where we talk about the air source heat pump. So again, you can see the most contributing factors there. There's some good work that can be done. So high scores at the moment are bad. There is going to be a lot of good work. There are things like, I think EnviroBlock had the first cement-free concrete block with an EPD. So again, that will be significantly reducing the concrete block element. But again, it's highlighting stages that you can see there. And it basically relates back to an air source heat pump. And I don't want to try and confuse people or try and make people think differently about air source heat pumps. What the analysis is showing over the RIBA Climate Challenge is based over a lifespan of 60 years. So what they're saying as part of the replacement and maintenance is every 17 years, I think the air source heat pump has to be replaced according to the criteria. My point, again, it's showing that 19% of the total embodied carbon is attributed to an air source heat pump, but that's mainly true to the hydrofluorocarbons. Again, there's lots of good work being done there. We have to use a life cycle assessment to work on what's going to happen, but can we predict what's going to happen in 17 years' time? It's not going to be replaced with a like-for-like air source heat pump. That is 100% sure. In 60 years' time, the building would hopefully still be up, for one. But again, you know, the technology is going to have changed significantly. So it is a bit harsh to sort of say that, you know, that's the attribution is 19%, because in reality, in 17 years' time, you're probably going to have something that's got a really, really low GWP score and can be fully recycled, for instance. So again, I don't want to try and mislead people with what this is trying to say. We had a look at masonry versus timber frame, and again, we're independent. We sell to masonry, we sell to timber frame, we sell to all sorts of various different weird and wonderful structures beyond this as well. But again, you can see there, it's about using materials that are available now. So everything that was done was what's available in the marketplace now. What are people building out of? It's no good going to Finland or Germany and getting the best EPD of a product that we're not using. So again, using the EPD scores that are available with the materials that we're buying now, there is an improvement from a timber frame point of view that we saw. It was 2.85% on the semi-detached, slightly more on the detached, slightly less on the mid-test. So again, it is better, but it's about choice. So again, we're not telling you what to do here, what to use, we're just telling you what we found. And again, if you're a bricklayer, you're going to want to build in brick and block. If you're a chippy, sorry, you're going to want to build in timber frame probably. You're a national house builder, it doesn't matter as long as it's cheap. So again, it's about choice. There's lots of considerations. It is a moving target to a certain degree. I talked about EN 15804A1 being changed over to A2 in July. Again, we are current with that. Again, data is changing as things go. Standards for EPDs, again, you can see there as calculated. So it is an ongoing thing. It's something that we're working with constantly. So just looking at some insulation specifications themselves. So we've talked about targets for 0.18 and 0.15. We've included 0.13 within the targets because that's the Welsh notional dwelling as of 23rd of November of last year. So again, we've got there a full fill insulation PIR that can achieve 0.18, 0.15, 0.13. A partial fill insulation, again, 0.18, 0.15, 0.13 can be achieved. From a floor point of view, it's 0.1, 0.11 and 0.13, 0.11 in Wales. But again, these targets can be achieved on block and beam, ground bearing slabs. The way in which calculations are run are also slightly different. You need the resistance of the makeup of a wall or a floor or a roof. Typically on a floor, you'd also need to know the exposed perimeter and the gross internal floor area. So again, if we ever ask for a drawing or the P over A, that's why. So we just need that calculated. Exposed floors change, they're just a resistance, and therefore you just need to know the makeup and obviously what that's made up of from a conductivity to work out that resistance. So most insulation through the bottom chords are mineral fibre as a build-up. We also do crawl boards, PIR with OSB over the top for plant, just reduces the thermal bridging. Pitch roofs, so again, similar to the resistance that you need for other elements, we need to know the centres and the depth. And again, we would always recommend if we're doing insulation between that you also insulate above or below as well to mitigate that thermal bridging. Or of course, you could do it completely over the top as a warm roof as well. So again, this is an approved, it's a RIBA approved presentation. As part of the RIBA approved presentation, they asked us to talk very briefly about fire. Part B of the building regulations changed on the 1st of December, which limited buildings in England to 11 metres from a combustible insulation point of view. Again, that was brought down in line with sprinkler systems. So again, various documentation. Obviously, you can look at Part B itself and the diagrams of how that actually works from the external finished floor levels up to the highest point of the habitable finished floor is how you measure it. So it's not from external to gable height or anything like that. But again, this is all outlined in Part B of the building regulations. And I'd just say if any of the information is unclear or whether you're unclear, please contact a specialist or a fire engineer who would be able to give you more information. So the learning outcome, I know I've gone through this fairly quickly. I'm conscious of time and I probably would have wanted to spend more time, but again, I'm conscious of everyone's time and getting some questions in. So there is a learning outcome and the learning outcome is the same as the agenda. So hopefully you've learned what we were meant to go through. And this is me. So if anyone wants a copy of the presentation or a certificate, for instance, I think I saw that come up quite early on, then again, I'm happy to put a certificate across to you.
Great, thank you so much for that, Martyn. It's really interesting, and I appreciate that the talk is originally tabled to be, I think you mentioned it at the beginning, was it over an hour? Yeah,
so it's basically it's meant to be within an hour, so 45 minutes to 50 minutes with a 10-minute Q&A, a 10-minute Q&A. But we've had the presentation, as you can imagine, go on for a lot longer because there's a lot of slides. It depends on the interaction, so we can take as long as people need effectively, or we can rattle through it like you see I've done. But it's a very data heavy, quite a very interesting topic. But again, one that's relatively new. So.
Most definitely, yeah, really interesting. And you mentioned that you'd be happy to give CPD certificates. Did you want me to share your email address for people to get in touch with you?
Yes, no, please do that. Yeah, so you can share that, and I'm more than happy to do the certificates and give copies of presentations. We've got the ex-CO2 report itself in more detail, so I'm happy to give people copies of that, and obviously any further information anyone wants as well.
So sorry about that. Just trying to do multiple tasks all at once, so bound to make a mistake at some point. So yeah, if we just run, I'll share your email address in the chat box, and obviously if anyone does require it, then please get in touch with Martyn directly. And also, if you do have any project-specific queries, obviously if there's something general that you feel like we might be able to touch on and benefit everyone, then please do ask away. But if there's any project-specific queries, then it'd probably be best for you to take that offline and discuss that in detail with Martyn and potentially maybe some of his colleagues. Also as well to highlight is that this talk will be made available via YouTube in due course, and we will also, as soon as Martyn sends across the slides, we will be making the slides available to everyone that's registered via Eventbrite for the event. So please do keep an eye out for that. So I'll just try and scroll down to one of the questions for you now. So a funny one, I guess. Alex kicks it off with, it's interesting that no metric exists yet, and yet planning authorities are setting ambitious targets to be achieved in this respect before the metric is agreed. Seems the cart is going before the horse on this.
I couldn't agree more. So I was having the conversation with Southham's from a planning policy point of view as well, just trying to determine what it is they actually want. And again, there are other people and there are other ways of running embodied carbon. You can do it through Design Builder, you can do it through an Excel spreadsheet. But again, having the metric to follow and the guidance that you have with somebody like RIBA or LETI or obviously CIAT are doing something similar, which they will work and it will look very, very similar to the RIBA Climate Challenge. So is necessary, and having a way of offsetting that carbon and stuff. But specifically on planning, I was bringing it up with them and others in the UK Green Building Council today. Are we at a stage where we're telling people what they're building at planning stage? You know, what materials they're using and stuff, because you can't do this accurately. We can all put our finger in the air and have a guess at what the embodied carbon is going to be. It's not difficult. But actually looking at the difference between, is it masonry, is it steel, is it going to be in situ concrete? There's all sorts of different things it could be, but you're making that decision potentially at planning stage for somebody else. How's that going to affect costing and everything else? It's choice. You know, how is it going to affect ongoing sales, you know, trends at the time and materials available? There's so much more to think about than just saying, right, we're going to blanket policies. And that's what we're really trying to do. This isn't a product selling exercise. This is an educational one. And we're trying to do the same with local authorities and sharing our expertise and what we found with them as to how life can be made easier. And I'd welcome anyone, again, that goes through that planning policy to share ideas with me, because we'll share them again with local authorities.
I mean, generally, just responding to that slightly, is if you think about it in holistically as possible, it's almost as if the entire industry at every single level needs to move in that direction, because we're talking all the way down to maybe a nut or a bolt, all the way along to sort of the mass elements of a building. Everything at some point depends on how detailed we're going to consider everything. But at some point, if we're going to be thinking about an entire project or entire area, at some point everything will need to be considered.
It will. It's currently not. So when you look at the Royal Institute of Chartered Surveyors guidance, things like the external walls are 4 elements. When you look at things like wall ties, trays, lintels, they're not considered because they're not considered a big element. But if I was a manufacturer of a lintel, say Catnick or another, I'd want to be proposing my EPD that's slightly better than my competitors to show that we are considering environmental impacts and stuff. But again, as it becomes more and more regularized, which it's not currently, so when we get Part Z and stuff, things will be a lot clearer. The greenwashing that we have in the industry at the moment under EPDs perhaps will go away a little bit.
Exactly.
And it'll be a little bit easier for us to understand. So it is early days.
We've got, for the moment anyway, I haven't scrolled all the way to the bottom yet, but we've got about 2 or 3 which are very specific and detailed. So I'll go through them. So we've got Sean, who's come back and referenced, you mentioned about litres per day being 141 per person. He felt as though that's a lot. And he was wondering whether that included for wastage or inefficient, maybe poor infrastructure, say for example leaks, but then I do know a lot of people don't really understand how much shower water it uses and things like that.
Yeah, I think so. Obviously, based on existing housing stocks, and it's information taken from RIBA, so it's not our information that we've come up with. Again, it's looking at older stock, so a lot of older stock and baths and stuff like that were a lot bigger. So we're looking at all of the stock rather than what's new. So obviously, when we know what's new now, we've got Part G water caps that we have to do, which is 125. So it's not too dissimilar, 141 to 125, whereas 75 is a lot less. So no, it doesn't take into account, as far as I know, for leaks within the systems, which again is for where I live in Devon, a Southwest Water issue, and we know their network leaks like a sieve.
Yeah, exactly. And then we've got a question in from Chris. If air source heat pumps are proven carbon heavy over its lifetime, what alternatives would you suggest or have been tested and proven to be better? And I guess maybe further on that is obviously, which you touched on, is air source heat pumps are a relatively new technology comparative to others, and this is obviously something which will be developing in years to come.
They are, and they aren't, because it's a refrigeration unit, and we've had refrigeration units and air conditioning units for years. So it's not the technology. It's more about at the moment the hydrofluorocarbons and stuff, and this is why we have problems getting rid of freezers and stuff, and why nobody wants to take them is because you've got to break that down, and it's a real problem. But like I stressed, there are other boilers. There's all sorts of things. There's fusion stuff where they're trying to replicate what the sun's doing, which is going to be as big a problem to get rid of as anything. But there are friction boilers and stuff which will work. Hydrogen boilers which will come online, which are zero CO2 emissions. Probably will be 100% recyclable, so they're going to be a lot better, but they're not going to work like an air source heat pump. You're not going to have one unit in, 3 units out. So what I was trying to stress in the presentation, and what in my mind the presentation tries to do is give a different view on air source heat pumps. In 17 years' time, when you come to replace it, same as I've got to replace my oil boiler now, which is probably just as old, it won't be replaced with the same one. It will be far more efficient. It will be recyclable. It's something that we have to do. So whilst we can tell you what we do now, so I'm being overly honest, there's products like ours that at the moment we've got to say that they can't be recycled. And it's not that they can't, it's just it's not being done. So in 17 years' time, when you have a volume of it, is it going to be done? I don't know. It should be. Commercially, it should be. Plus the sustainability push that we've had will make us do it anyway. But we have to tell you what we're doing now for 60 years' time. And that's the problem. Whilst we have to look at a whole life cycle assessment, you don't really, you want to look at it with your eyes open, effectively, is what I'm saying.
Yeah. No, definitely. I guess maybe something more tangible for everyone, if they're not fully understanding that, is maybe if you think back 17 years, your mobile phone, what was it like then, and then what's your mobile phone like now? So almost using that as a sort of technology leaps. We've got a question in from Richard. Can you explain sequestered carbon, and when are the figures applied / deductions made?
So when you look at stages beyond A5, so B stages and beyond, and the recycled stages, when you can use sequestration. So sequestration is the taking in of carbon during the process. So something like a tree that's growing will sequester carbon as it grows, and in which case it stores the carbon. It does then, when it comes to actually disposing of it, a lot of timber is incinerated, in which case all the carbon is released. So again, it's a complicated subject. A lot of people will tell you that obviously look at everything that's sequestered, look how good it is, but there's an end of life process, what's happening to it. Whereas carbonization is the upfront carbon that happens at the time. So something like concrete is high in carbon in content because of the carbonization that happens. So
we've got a question from Stephen. Have you done any work on using an AI to validate CAD drawings, etc.? And maybe, I guess, further again, in regards to, you briefly mentioned it, saying that I believe Autodesk Revit are developing some tools in regards to this. Maybe that's tangential, but it feels appropriate. That's all.
Yeah, so design builder that we model overheating on, and model SBEM. So from an energy assessment point of view, have built-in carbon, embodied carbon scores as you build the models up. So that's again another way of looking at things, I guess. If that kind of answers some of the questions, I guess.
Yeah.
So there are ways, and Revit's linked with Design Builder, obviously, and stuff. So you're going to get to the stage where you click on something like, the full extent of, here's the DOP, here's the brochure, here's the embodied carbon of that product as well. So how that all interlinks then into actually measuring it, because you need to quantify it and stuff like that, which will all be done in a process in the background, I guess, and then spitting out an embodied carbon score.
Yeah, exactly. Sorry, I'm just quickly scrolling. I think a lot of people got excited about the idea of getting certificates. So
I've seen 1 or 2 emails come in.
Okay.
Did anyone look into their own embodied carbon from a carbon footprint point of view, Usman, while I was
Yeah, so I did share the link for the WWF app, so I'm sure a load of attendees may end up downloading that just to sort of give themselves an idea in regards to their figures. I've getting some people coming back with 10.7, another one with 10.1 for their score. So a 9.57 from another. So it looks like, yeah, quite a lot of people have a 9.5 another, 7.7 from another. So it looks like quite a lot of people have looked into this. So that could obviously get.
Well, I think from my point of view, just to go back onto it, I honestly don't think, or don't know who we think is going to solve the problem. If we're not looking at ourselves and understanding what we're doing, you know, we can't just rely on businesses. And I said the same to Unilin. I did a sustainability chat for the whole of our group, which included over 8,000 people who all had to log in. And I said the same thing.
Yeah, most definitely.
8,000 people here as voices. So.
Most definitely. I think that's probably a really good point to sort of bring it to a close on, and obviously please respond. But like you're saying, that this is quite a wide reaching change in which we're looking to review our current processes where we might be backtracking on, and looking at maybe moving forward in the future as well to sort of a more sustainable and I guess living in more harmony with regards to the world, and sort of seeing that we're not almost filling up holes where we're throwing things in and covering them over, and trying to find more things. So almost trying to reuse, go back to the principles, reduce, reuse, and recycle as much as possible. And also then, in addition to that, also thinking about how we can reduce the embodied carbon energy just generally.
100%.
So is there any sort of closing statements that you'd like to make as before we bring this to a close?
Look, I think obviously I'm seeing a lot of emails come through. I'm assuming most of them are probably for certificates. But again, if you've got any questions, we try not to talk too much about product and what we do from a service point of view. But again, if anyone has projects, please do share them and see how we work. We are slightly different to most manufacturers from an installation point of view. So.
On that matter, would they contact you directly, or would they contact the technical department? What would be the best way?
I think initially they've got my details. So again, make contact with me as a specification manager, and I'll point them in the right direction or assist them if it's something I can do.
Okay, great. Well, thank you so much, Martyn. And like I mentioned to everyone, we will be sending out an email to all of the registered attendees, which will include the slides. This talk will be then uploaded to YouTube in due course. And also, if you would like to request CPD certification, then please do contact Martyn directly. I've put his email in once again. But thank you everybody for attending our first in our calendar for 2023 for CPD and 43. We look forward to seeing you in the coming months for all of the other events, and we will be releasing a schedule of events in due course. So please do look out for that.
Thank you, everyone.